Hey everybody, I've got another factoring tutorial for you. Now, looking at this problem, I see that there is something in front of my x squared. There's an a value other than 1. Now, this oftentimes means that we're going to have a harder time, that this is not going to be as easy to factor. But hey, every time you look at any factoring problem and you see a number in front of the x squared, I call that a quadratic coefficient. The first thing I should do before I start trying to multiply a times c and starting that process, I have to just do a quick check and see if maybe this is actually secretly an easy problem in hiding. The way to do that is to look and see if there are any greatest common factors that could be factored out of this problem. You always want to look for that first because it will make your life a lot easier if there is. So to look for greatest common factors, I look and see, usually, I like to look at my smallest number, and I just see if I could divide all three numbers by that smallest number. In this case, 3, I'm just going to look, could I divide 21 by 3? Oh, yeah, I totally could. How about 180? Could I divide 180 by 3? Yes, I could. That means that 3 and 21 and negative 180, all three of those have a factor of 3. Since 3 is the greatest factor of itself, that's got to be the greatest common factor for this problem. Here's what factoring that out looks like. I just write the 3 on the outside of parentheses, and then I divide each term by 3. Now that looks a little bit easier, and if you watched my previous video on factoring easy trinomials, you may notice that that's actually the exact same problem I went over in that video. But really quick, now that I have this trinomial, I can factor what is inside of the parentheses here. I'll do my standard trick to the side and look for two numbers that fit the criteria of multiplying to negative 60 and adding to 7. Negative 60 is 1 times negative 60, and 7 is my middle number. I do a little bit of thinking, and I end up coming up with, I think that would be positive 12 and negative 5. Great. So that means that I can simply just put in 12 and negative 5 as my constants in these two binomial factors. Bam. Go ahead and square my final answer. So this turned out to be an easy factoring problem. It was just in hiding.